everyone. This lesson's about algebraic properties of equality, mainly definitions with a few examples. They include addition, subtraction, multiplication, division, and substitution. And we're also going to talk about the reflexive, symmetric, and transitive properties of equality. So here are your algebraic properties of equality. So basically it says if A equals B, then A plus C equals 2 plus, or B plus C. So if I let A equal 2, so I have, if 2 equals 2, so A equals B, I can add a C, call it 3, and that's going to be equal to each other. And we'll do some examples on all of these. The substitution property, if A equals B, then A can be substituted for B in any equation or expression. Now, you've used all of these before. You probably didn't have to write down the properties, but in geometry, you need to write them down because we do proofs. So let's do some examples. And they did it horizontally, so I'll do this more vertically. So we have 2x plus 3 equals 9 minus x. Now when you do proofs, that's just your given. That's your first line. Now to solve for x, we're going to add x to both sides. And that's the addition property of equality. So you get 3x plus 3 equals 9 plus 0, or just 9. And then we're going to combine like terms, or actually they kind of left one out. We can subtract 3 from both sides. And so this one's kind of wrong here. So this is 3x equals 6. That's your subtraction property. I'll just put subtraction property of equality. And then we're going to divide both sides by, oh, I see what they're doing. They're just adding these up. They're adding like terms. All right, so that's okay. So a lot of times we skip steps. So now we're going to divide both sides by 3. That's your subtraction. No, that's your division property. Oh my goodness. We already did the subtraction. So that's your division property. So you get x equals 2. So you've done this before, but you didn't have to write all this down. All right. Next, the distributive property. So basically, there it is. And what you're going to do is we have negative 4 times 6x plus 2 equals 64. That's your given. So you just write it down. And then we're going to distribute, or you actually could divide first both sides by negative 4, but let's distribute like they did. Negative 24x minus 8 equals 64. So we just used our distributive property. And then we're going to add 8 to both sides. That's your addition property. So you get negative 24x equals 72. And then we have our division property. So if you divide both sides by negative 24, you get x equals negative 3. All right, so like I said, you've been doing this all along, but you haven't had to say what you were doing. All right, here's some more examples. You can try those out. We didn't use this one yet, so let's just move on. You can try those out. And now our next properties are 3 more: reflexive, symmetric, and transitive. And under reflexive, you have your real numbers way to do it, your segment length, and your angle measure. All right, so that just means like A equals A, or AB equals AB, or the measure of angle A equals the measure of angle A. Their symmetric means you can switch them. So basically, let's just look at this one. If the measure of angle A is 30 degrees, and that equals the measure of angle B, then you can switch that around and do that. All right, in the transitive property, that is more like if A equals B and B equals C, then A equals C, like that. So I think the best way to look at this is through the examples. So the first example is show that CF equals AD. So let's look. I'm going to draw it here. CF equals AD. Now the reason you can tell that, so AD, so there's this A, B, whoops, B, and C. So I'll put C here, and this is D, and that equals CF. And all you're going to do is add your ticker mark. So we have CF, C, D, E, and F. So we have a ticker mark there, 2 there, and these don't have one. We could put 3 here. So that's called your segment addition postulate. And then to show that they equal, you're going to use your segment addition postulate through the substitution property of equality. All right. And then you're going to go down, and instead of writing all this, you have DF equals BC plus AB. So DF equals AC, because AC equals AB plus BC, because these are the same. So that's where you get your transitive property of equality. Then we're using the addition property of equality, and then the substitution property. So we substituted DF plus CD with CF. All right, and this one's already written out for you, so we're going to leave this written out. But we're going to look at number 3. It says, suppose the equation in example 3 is D equals 5 times S plus 3. So solve for S. So what I'm going to do is distribute. So that's 5S plus 15. And to solve for S, I'm going to subtract 15 from both sides. So that cancels. And that would equal 5S. And then divide both sides by 5. And that cancels. So that's your division, because we divided. All right. And if GH equals JK, then if JK equals GH, well, we're talking about a segment length, and that's your symmetric property. And then we have R equals S, and S equals 44. Therefore, R equals 44. That's your transitive property. A equals B, B equals C, then A equals C. These two equal. So these two equal. All right, and then if you have something like that where they're exactly the same, that's the reflexive property of equality. And that is for angle measurement because these are angles. And, oh, I just did this one. So that was just the extra thing there. So that's it. Thank you. Have a nice day. Bye-bye.